All right, welcome back, everybody. Glad to see you all here. Let's see. Let's just go ahead and get started with what we're getting into today. So we're going to continue with these logic paths. Sorry, just the logic stuff. That's just kind of what it's called. You know, like Venn diagrams and logic. Or I have that logic chart that I'm trying to get to right now. Right, so logic statements. So, you know, if this and that, or and this and that, this or that, you know, those are all the things in the conditionals. Right, so we're still following along with logic. So how do we kind of prove things is kind of what we're getting at, you know, if and then statements. Ooh, I think I went too far down. So this next one here is deductive reasoning. So that's what we're working on today, is deductive reasoning. So the process of reasoning logically and drawing a conclusion from given facts and statements. So if you think about like anything, like maybe a history class, you know, a lot of times when you think of a history, like when they make assumptions about history, you know, sometimes they'll find something, they'll find an artifact, something that people once used, and then think, okay, well, what could it be used for? Why would they use it? Why would they have it? You know, so they're given something to work with, and then they get a reasoning behind it. And almost all fields of science are like that. You kind of have information, and then you have to get something from those information. So law of detachment. So I know some of these are a little bit tough to kind of get the names of because it's like detachment. You know, a lot of us probably wouldn't have any experience in what that word means. So given a conditional statement, if the hypothesis is true, then the conclusion is true. So remember, hypothesis is what you think is going to happen, and the conclusion is what you kind of get from that hypothesis. So if the first one is true, if the first condition is true, then the second part is also true. And I'm gonna just use the examples here. So sometimes I know I like to make my own examples, but I'm gonna go right into it. And you write it something like this. So we already know this first part. P implies Q. Or in this case, you could also say caused. So P causes Q. We know that there is P, or P has happened. Therefore, Q will happen. So we know that something has happened, right? So let me make another example. Let's say we have a ball, which I have one right here. There's a ball on a hill. And if you don't touch it, it stays there. We know that this ball is being pushed. That means it's going to roll down the hill. That's kind of a quick example that you can imagine it. So we know that the ball was pushed when it was balanced on that hill, so it's going to definitely roll down the hill. And we have that weird symbol for therefore. Actually, this is the first time I'm seeing it too. Again, I haven't taught geometry in a long time, and geometry has changed a little bit since the last time I taught it. So there is a little bit of things I may or may not know, or things that are a little bit different. Like that V symbol, okay, back in my day, we had a U symbol and we called it union, and the upside down U was called intersection. And it looked like that A without the middle joining piece. So sometimes I do run into things that are new and different for me. I don't know, they change things, kind of like if you haven't driven a car in a while, like if you were, I don't know, trapped in ice or something, and 20 years from now you awake and now everything's different. You know, things are going to be different from the way you remember them. All right, so anyway, get to the directions. So use the law of detachment to give a valid conclusion. If it is not possible, write no valid conclusion. So we have to follow the logic, okay? We have to follow what they gave us. If the logic, or if the statements they give us don't follow the logic, then we can't say, well, then this is going to happen. We have to say it's not valid. Okay, that doesn't mean it's impossible. It just means that following what they give us doesn't make sense. Then it doesn't make sense. Oh, I guess my ball is gone. So let's look at this one here. So again, we have condition P and Q, and this one's broken down into a conditional. So if Mark saves $30, then he can buy a new video game. All right, so we have the if and then statements. So that one separates the P statement from the Q statement, right? The first one is he saves $30. The second is that he can buy a new video game. Now one leads to the other, right? That arrow. If you save $30, you can buy that game. Now we know in this case, he did save $30 because it's given and it's telling us he has $30 now. That means he can buy a new game. Okay, probably not a new game, all right? Because I know new games are usually like $60 or $70. Or maybe that's only if you're talking about like a major title. I've been trying to get that new Final Fantasy VII game, but I don't have a PlayStation, so I'm waiting till it comes out on PC. But I think the price is like $70 or something. But either way, he can buy that game, or maybe this is from the Xbox store. I know games there are usually like $5 even for older titles. All right, so next one, number 2. If a quadrilateral is a rhombus, then it is also a parallelogram. So if it is a rhombus, okay, rhombus is sometimes we call it a diamond shape. So that would be a rhombus right there. So we know, it says here, this quadrilateral, it tells us it is a rhombus. So this is called ABCD by its points, by its vertexes, actually vertices. It says it is a rhombus. So if this shape is a rhombus, then it is also a parallelogram. It is a parallelogram, right? Because opposite sides are parallel. The top is the top is parallel to the bottom, and the left is parallel to the right. So we know that this must work out. So let's look at something that does not work out. What is a situation where this does not work out? So if you are 18 years old, then you can register to vote. All right, well, Olivia is not 18 years old. Now you might think, well, that kind of makes sense. What about, wouldn't it just be then Olivia cannot vote? But that one doesn't work, it doesn't work out the same way, because if you look at the second one, it's been negated. It has a not in there. So in this case, Olivia is not 18 years old. So again, the logical next step would be negate the other side. That would be then you cannot register to vote. Then she cannot register to vote. But in this case, it's not valid conclusion. So no valid conclusion because it does not follow the rules that we were just given, 10 minutes ago or whatever. So negation doesn't work out because if you remember, we can say some statements can be negated, like a not squirrel is not a rodent. Yeah, because if it's not a squirrel, then it is most likely not a rodent. But actually that doesn't quite work out because there are some rodents that are not squirrels, like bunnies and rats, right? So it doesn't reverse, not all logic reverses. So that would be no valid conclusion. So we can't have any negation statements. Okay, so let's go ahead and go to the next one. So number 4, the sum of the measures of two angles is 90 degrees. So we have two angles and we know that they add up to 90 degrees. Then that means they are complementary. So there's our second statement, there's our first statement. And it gives us angle J is 58 degrees and angle K measures to 32 degrees. And it says JK is complementary. So the sum of two angles is 90 degrees. Well, the sum of these angles is also 90 degrees. So these two angles, J and K, must be complementary or are complementary. So again, it has to follow that same thing. This leads to that. So this should lead to that also. So if we know this is true, then the second part is also true. Number 5, if you plan to attend prom, you must purchase a ticket. Sarah purchases a prom ticket. Now this is the converse. That means you switched the order in which it happens. So it should say, if you plan to attend prom, then you must purchase a ticket. Sarah plans to attend the prom, so Sarah must purchase a ticket. That's the way it should go, but they reversed it. So we have statement Q, then statement P, which is, again, it's converse, switched backwards. The hypothesis and conclusion have switched places is what we would say. So it doesn't work in the converse either. The inverse and the converse and the negation don't work out the same way. So in this case, it's not a valid conclusion. And if we follow if we ask ourselves, does it make sense? Okay, so just because she purchased a ticket, does that mean she will go? No, I mean, she could buy a ticket. Maybe she bought it for somebody else. So if she bought it for somebody else, then she's not going, because we don't have enough information to know if she is definitely going. All right, so I'm gonna go ahead and move on down to the next thing. And we go to this one, and I had to look up this thing here too. So I'm gonna go ahead and switch over there really quick. I know some of you guys are probably getting writing this down, but the problem was, like, this morning I was looking at that and thinking, is it syllogism or syllogism? Because again, this is kind of a new thing for me. I mean, I've been a teacher for 10 years and I've taught geometry, but that one's new to me. And even so, I want to make sure I'm saying it right, because the weird thing about English is that sometimes our G and J's switch pronunciations, like giraffe. Like giraffe kind of sounds like a J. Garbage sounds like a G. And it doesn't make sense. And especially when you go to other languages, like in Spanish, J makes a H sound, and then in Swedish, J makes a Y sound. Yeah, like Jaeger. Anyway, I'm gonna go ahead and just switch over to the screen and let it pronounce.
Syllogism, 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 syllogism.
There you go. So now you know I'm saying it right or wrong. So what that means is that it allows you to draw a conclusion from two conditional statements. So again, a conditional statement is if and then. So, you know, someone asks me, do you want to go to Flagstaff? And I'll say, well, okay, on the condition we go to Verizon. So I would say, if I go to Flagstaff, then I will go to Verizon, or I will go to if we go to Verizon, then I will go to Flagstaff. All right, that's an example of the conditional statement. So I know there's a lot of words, a lot of vocabulary, and a lot of like, okay, what did that mean? But again, it kind of makes sense when you think about it. So just thinking about it, the word conditional should make sense. If and then, right? This morning I had to send out a if and then statement to students, and it, you know, that's just the way it turns out. I didn't mean to do it, but I said, if you have a lot of absences, then you will be dropped, right, from summer school. And I said a couple of other things too, like you guys knew what you were getting into when you signed on for summer school. The summer school packet said you must be at Zoom. So if you signed up for summer school, then you must be ready for Zoom. And there's lots of those statements like all over. You probably made a couple of them just this morning. All right, so those conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. And again, it sounds confusing, but if we look at the map, it actually kind of makes a little bit more sense. So if P leads to Q and Q leads to R, therefore P also leads to R, okay? So back to that example, I don't think I have it anymore. I was looking for that ball, but it rolled off and it's gone now. But if I took that ball, right, if I pull that ball uphill, then I let it go, it will fall, right? So therefore, raising a ball will usually means that it will fall. Now this is also a similar property, so I'm going to go with a different story. So actually, this is something else we are also going to cover for this lesson today, and that is the law of, the transitive property. Transitive property. So like in that case, you might have a statement like A equals B, B equals C, therefore A and C must be the same. And again, we're going to cover this in the same lesson today, so I'm going to go ahead and just leave it at that. But again, one leads to the other leads to something else. So the first thing causes the second, the third thing. Oh no. I'm going to make a note of something really quickly. All right, I'm gonna, sorry. I was pretty sure I sent that Zoom link this morning, unless somebody didn't get it. All right, so hopefully that gave you some time to write these down, because I'm gonna go down and we're gonna start covering the examples. So let's see, if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Now following, if we look at the pattern here, Q is the second on this one here. So if the first one starts with Q, then it works out. So again, you have to follow that same path. So if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack a lunch. So now the conclusion is, if it is Saturday, Jake will need to pack his lunch. So in a way, we cut out that middle step, right? We cut out that middle step. And that's pretty much what's happening. Oh, excuse me. So since they both have baseball tournament, then we just go with the first statement means the same as the third statement. All right, so let's try another one. This one's kind of a math one here. So if a number is divisible by 12, then it is divisible by 6. All right, that makes sense because, you know, there's no numbers that can be divided by 12 that can't also be divided by 6. If a number is divisible by 6, then it is divisible by 3. Well, that one also makes sense too, because again, if you can divide a number by 6, you should be able to divide it by 3 as well. But you notice how the end of this one says divisible by 6. The beginning of the second one says also divisible by 6. So if a number is divisible by 12, then it is also divisible by 3. That again makes sense. Now again, with these ones here, I know sometimes I say, well, you should ask yourself, does that make sense? But in this case here, I know someone might say something like with this baseball example, well, what if it's a Saturday where there is no tournament? But again, you're following this chart, this map right here, this symbolic map right here. That's what you're following. Okay, so next one here. So if a quadrilateral is a square, all right, first one. Second one is, then it is a rectangle. Then another statement says, if it is a rectangle, so again, we're talking both of them are rectangle, so both second statements are rectangle, then it has 4 right angles. So conclusion, if a quadrilateral has a square, If a quadrilateral is a square, then it has 4 right angles. So again, they remove the part where it says it's a rectangle, because we already know that both of them are referencing that they are rectangles. So we can say that this statement leads to that statement, even though they're in 2 different statements. All right, so this one's a bit of a different one because as you can see, there's no valid conclusion, but what makes it that way? So if we look at it, it says, if it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. So why doesn't this make sense? Doesn't that make sense? If you go boating, you should wear shorts. That makes sense. If it's sunny, you go boating, and if it's sunny, you wear shorts. But there's no conclusion on this one because it doesn't follow the map. Now, to make this one work, we would probably say something like this. If it is sunny this weekend, then you will go boating. If you go boating, then you will wear shorts. That's what it would be. Then the conclusion would be, if it's sunny, you will wear shorts. That's what it should be. But again, it doesn't follow the same thing because they both start with, it is sunny this weekend. And that's not the way it works out. It doesn't follow that path. And let's try this next one. Let's see what's going on with this one. So if you shop at Target, then you will use your red card. If you do not use your red card, then you will not get 5% off. Now somebody might say, well, wouldn't it say if you shop at Target, you will get 5% off? But that second statement contains negations. They added the word not in there. So if we wanted this to work, we would remove the words not. So it's, if it said, you do use your Target card, then you will get 5% off. That would make sense. Then we could say you shop at Target, you get 5% off. Right? Because, you know, I don't think Walmart has anything like that. I don't think any other stores really have anything like that. I know some stores you have like, you have something like that. Like, I know there's a Safeway card, but you almost never get discounts with it. Or you'll, well, actually, no, you do. You get like a couple cents off of almost everything, which adds up. But anyway, yeah, because that second statement is negated, has negations in it, that's going to be not valid because, again, this doesn't have the little squiggly lines on the map. If it had the squiggly lines on the map, then they might give it its own name and its own property and all that stuff. But again, negations aren't always true. Okay, so next one. If it snows, school will be canceled. If school is canceled, then students will need to make up that day of school. All right, so that's the given. If it snows, school will be canceled. So this one ends with school being canceled. The next one begins with school being canceled and then has a separate then statement. So we could go with this if and then that statement. So if it snows, then students will need to make up a day of school. And that makes sense. Well, in a way, again, don't get too bogged down with a lot of these examples because I know someone's going to say something like, well, what if it lightly snows? What if there's only a little bit of snow? Kind of like with Tuba City, you know, you get like a little bit of snow and people are like, oh man, we should call off school, but there's only like a little bit of frost on the ground and it's usually gone by noontime. All right, so again, don't worry about, you know, picking the example all the way through. Just ask yourself for now, at least for this assignment, does it follow that rule, follow the logical rule of one leading to the other and so on? That's the only thing you're really looking for. Don't ask yourself if it makes sense because I'm pretty sure someone's going to say something like, well, what if you forgot your red card, but you ended up at Target? All right, let's go ahead and move on to the next one. Or actually, I think that is both of them because this was law of syllogism and this one was law of detachment. So for this one here, we're gonna tell them apart, right? Because we have two of them and they are kind of the same. They both have that mapping diagram of symbols. So how do we tell when, when it's this one or when it's that one? I'm going to scroll down just to see. Okay, so for this one, we have 2 pages. So there's 2 pages for this one. And I'm going to try to leave this one up here so that we can still reference it as we go through at least these first 4, then we'll kind of go down to the next one. Now, I'm not going to leave you a whole lot of time to write because in this case here, you're only writing like a few words, okay? Sometimes when I give you something to write, I'll give you more time because there's lots of definitions, lots of words and stuff going on. But in this case here, we only have like, we're only just writing 1 of 2 words or invalid, really. And again, don't get bogged down with whether these specific examples make sense, because I know some people are going to be like, well, especially this first one here. Especially this first one, we're not asking if it makes sense in real life. We're just asking, does it follow the rules that they gave us, on top of this page or in the previous lesson? So let's go ahead and I'm going to start going over them. Like I said, hopefully you don't need a whole lot of time. So given, if I drive over the speed limit, then I will get a ticket. And the other given is, well, we know for a fact we drove over the speed limit. Conclusion, I got a ticket. So this would be law of detachment, because law of detachment states that we know the first thing has happened, right? A ball is raised in the air. It is given, it is told that we let it go. That means it's going to fall. One leads to the other, and we know the first thing has happened, so that means the second thing will happen, right? This person drove over the speed limit, so they got a ticket. And again, I don't focus too much on the real life logic of it, because I know that you're going to say, well, my parent speeds to Flagstaff all the time, and they never got a ticket. Okay, so let's go ahead and get to the next one. Let's see, the next one is given. Amanda goes to a restaurant, then she will order a hamburger. If she orders a hamburger, then she will get fries. All right, because fries just go great with hamburger. That's just the way it is, okay? So with this one, it would be law of syllogism, because, well, we have one thing that leads to a second thing, and the second thing leads to a third thing. And sometimes, I'm like that too. Sometimes I go to a restaurant and I'm like, well, I'm going to try something new. Then I'm looking at the menu and I'm like, man, my regular food, the thing I usually get, sounds really good right now. I'm just going to go with my usual. So that's probably what's going on with this one here. So if the conclusion is, if Amanda goes to the restaurant, she will get fries. Well, that makes sense, because the second item is she will get a hamburger if she gets a hamburger. So therefore, we know that if she goes to the restaurant, she will get fries. So getting fries is pretty much a given. That's what's going to happen. She's going to get fries. Okay, so number 4. If it snows, then I will wear my snow boots. If it snows, then I will not go to school that day. Conclusion, if I do not go to school, then I will wear my snow boots. Now, looking at it, it does kind of make sense. If it's snowing, you wear boots and you don't go to school. So if you don't go to school, you won't wear the boots. You probably don't need to go outside anyway. And there's a lot of things. But again, we're looking at, does it make sense in terms of how the rule is written? In this case, it is invalid, because you might be thinking, well, wouldn't it be something like this? Because there's 3 statements, right? It snows, wear boots, not go to school. So there's 3 things. So you might be thinking it would be this one, but now this does not lead to that. It doesn't follow the rule. If it did follow the rule, it would read like this. If it snows, then I will wear my snow boots. If I wear my snow boots, then I will not go to school that day. Or actually that one doesn't, I mean, it follows the rules, but it doesn't make a whole lot of sense. But either way, you know, actually if you reverse it still would not make any sense. So I guess invalid is pretty much the only way you could do this. But again, mainly because it doesn't follow the rule. It doesn't follow the rule that we had earlier. All right, moving on to number 4. So given that Tina goes to the beach, she will wear sunscreen. Given Tina goes to the beach, Tina wears sunscreen, or therefore Tina will wear sunscreen. That looks like it might be law of detachment. But why is it? Well, actually, it is. Because in this case, we know she went to the beach, right? It's telling us if she goes to the beach, she will wear sunscreen. And now we know she went to the beach. So definitely she will be wearing sunscreen. And again, I know someone's going to say something like, well, what if she forgot the sunscreen or something like that? All right, let's go ahead and go on to number 5. And again, there's not a whole lot of writing in this one, so the writing shouldn't be that long. All right, so given if you get a cold, then you will eat chicken soup. Now, you ate chicken soup, so therefore you must have a cold. Does that make sense? I mean, it does make sense that if you have a cold, chicken soup somehow helps. But eating chicken soup doesn't mean that you have to have a cold. You can eat chicken soup when you don't have a cold. But again, that goes to show that you had the converse, right? You switched the hypothesis and the conclusion. If it said, if you get a cold, then you eat chicken soup. You must, or given that you have a cold, then you will eat chicken soup. All right, so if you reverse those second two statements, then it will work out. But again, switching statements or negating statements doesn't work out, or not putting them in the right order. So those are some ways that you can get them to be invalidated. So in this case, this rule does not work. All right, so two angles form a linear pair. Then that means that they will be, supplementary. If two angles are supplementary, then their sum measures 180 degrees. Now again, look at the middle statement. They are supplementary. So then they are supplementary. If they are supplementary. So we know that they are supplementary, then this one must be true to that one. So two angles form a linear pair, then their sum of angles is 180 degrees. Oops, sorry, push the. Okay, go ahead and go to the next one here. And this one does have a little bit of writing, and I think this is the last one we're going to do for this lesson, okay? Because remember, we have two lessons, and that should bring us right till the end. Okay. All right, so again, not a whole lot of writing, so I'm gonna go ahead and move on. Two angles measure 60 degrees. Then they are congruent. So we have two angles that are 60 degrees. J and K are congruent. Therefore, angle J and angle K must be 60 degrees. Well, that doesn't make, well, okay, so they reversed it. If it said, well, okay, well, this doesn't really follow either of the rules. Because one does not, well, one does cause the other. And it should be, if we wanted to make this work, because it is invalid, you can see it right there. If they wanted to make it work, it should have been, the given is that J and K are 60 degrees. Therefore, J and K are congruent. So you'd have to switch these two here, the given and the congruent, to make it work. but this would kind of be closer to law of detachment. Yeah, law of detachment. But again, it's not valid. It's not either of those. All right, let's go to the next one. So Kaylee gets at least a 95 on her final exam. She gets an A. Oh, sorry. If Kaylee gets at least a 95 on her final exam, she will get an A in geometry. Now, given that she got a 98 on her final exam, we could conclude that Kaylee got an A in geometry. So again, the first thing is, if she can get a 95, then she will get an A. We know for a fact she got a 98, so therefore she must have gotten an A. And that again is law of detachment. Because again, we know the first thing has happened, so the second thing must have happened also. All right, so if it is raining, then you must bring an umbrella. You bring your umbrella. Does that mean it is raining? Again, they switched the second statement. To make this work, they should have said, if it is raining, you must bring an umbrella. It is indeed raining, so you must bring an umbrella. That's what it should be. And if it did, then that would be law of detachment as well. Or maybe it said, if you bring an umbrella, then you are dry, or something like that. There would have to be a third statement in order for it to be a syllogism. All right, so that's it for that one. That one's just invalid. So I think that's it for this one. So we just go straight to the homework. Now with this one here, what you should do is you're picking some of these statements together. So here we have 6 statements and they're labeled A through F. So these 6 statements, some of them will lead to others. So we're going to use the law of syllogisms. So like we know that one is true, so therefore the other one must be true. All right, so again, here's a couple of them. So they're just saying like if A is D, and I'm not going to read all of them because if I read all of them, it would take a little bit longer, but they're there. Okay, you don't need to write it down, this part here, but you do need to write the statements 1 through 4 down. So A and D. So A says that if a quadrilateral is a square, then it has 4 right angles. Statement D says if a quadrilateral has 4 right angles, then it is a square. So you see how it says 4 right angles, 4 right angles? This one ends with right angles, that one begins with right angles. Therefore, A and D would make a law of syllogismic statement. Okay, I don't know how you would actually say that, but it makes sense, basically. It makes sense using the law of syllogisms. All right, so let's go ahead and look for another one. So in this case, they put BF. So if a quadrilateral is a rhombus, then its opposite sides are parallel. So what they did was they looked for another one that says if the opposite walls of a quadrilateral are parallel, then it is a parallelogram. And then they just removed that middle step here. So the middle step is opposite sides of a quadrilateral are parallel. It doesn't say it in here. They removed it because now we're taking the beginning of B and the end of F, and we're concluding that the hypothesis of B leads to the conclusion F. So I hope that kind of makes sense. So you can kind of look for any of these, and again, they're all here. So D ends in, it is a rectangle. E says that if it is a rectangle, so again, we know it's a rectangle then, we would just cut out the beginning of this one and the end of that one. So if a quadrilateral has 4 right angles, then its opposite sides are congruent. So that's another rule or law that we can basically prove is correct by removing that middle statement. And last one here is F and C. So F is the opposite sides of a quadrilateral are parallel, then it is a parallelogram. So again, they remove the it is a parallelogram, and they jump straight to statement C, which says we know it's a parallelogram, then its opposite angles are congruent. So basically, that's what you're doing. You're just trying to pull these together into statements that follow that rule. Okay. So I guess that's kind of it for now. We finished a little bit early, like 5 minutes early. That's not too bad. I'm trying to think. Well, anyway, that's it for the video. I'm also going to go into some of the announcements as well. So I know more people are here. I think some people joined in later. Oh boy, that's quite a lot of people actually. So yesterday we were talking about the attendance and the grades. Those are the two things that matter to you, pertain to you. So with the attendance, again, I sent out an email this morning kind of telling everybody, okay, no more missing days. The reason we decided that is last week was hectic, right? There was a lot of stuff going on last week. And I was one saying too, oh my gosh, I'm still getting students signing up. I'm still getting people enrolling in the class, and it's like almost done with week 1. So yeah, I had students showing up to my Zooms that weren't on my list, that weren't officially enrolled, and I'm getting like some students that are not enrolled, but they're doing some other program. And I had no idea what was going on, so I just sort of marked everybody that showed up and took screenshots and all that stuff. But now all of that's over. We're not getting any more students, okay? Everybody we've gotten in contact with, so we've managed to contact just about everybody who signed up for summer school. So everybody should kind of know what's going on. So from this day on, from here, starting tomorrow, okay, now I'm telling you, now you know, starting tomorrow, there will be no more absences, okay? And any absences that do happen are gonna have to be, you're gonna have to have a really good excuse, basically. If you go to the hospital, you will need a doctor's note, sort of thing. So that's what the packet said. If you remember the summer school packet, it said right on the front, Zoom class is required. And some teachers were saying, well, what if some students are really, really good at working on their own? Well, if you are in summer class, that means then you didn't do very good in the spring learning on your own. So you signed up to summer school knowing what you were getting yourself into. Using another if and then statement, if you read Zoom classes required on the application, then you should have been ready for Zoom classes. And summer school is not the same as regular school. In regular school, yes, we do need to say, okay, we got to make it fair for everybody. We need to make sure everybody has an opportunity to pass. So that's why we were excusing absences like left and right during the spring. But in summer school, it's not like that. Summer school is not required. It's optional. So therefore, if you, drop out or get dropped, that's on you. So I'm letting you know right now that you can't be missing any more days. And the same will be true with tardies. Again, yesterday I was kind of mentioning that. I was like saying, wait a minute, I got like some people that are really late. In fact, I started that policy of, when you sign in, you should put your name in the chat. And that marks the time that you were here, because I get a lot of students that are kind of being like, oh, well, I don't need to go to the Zoom, so I'm just going to sign in like 30 minutes late. Now there's a time limit. If you sign in or show up beyond a certain time, then it counts as an absence. And I don't know, maybe you could get your time from the other teacher, right? But I'm not going to tell you the time. You know why? Because if I tell you what time you're going to be marked absent, everybody's going to be trying to sign on 1 minute before that time limit. All right? You are not getting anything by signing in a few minutes late. You're not getting 5 extra minutes of sleep. You're not getting 10 extra minutes of sleep. There's nothing that you can be doing in the 5 to whatever time limit that I'm setting that you could get that would make you better at your Zoom class. In other words, you're ready now or you'll be ready never. So I know sometimes there are internet issues, okay? But if you can sign in, even just if you show up, that counts, okay? That counts. If your internet is really bad, just for today, you know, there's always the videos. There's this video right now that you could be watching that tells you what you need to know. You know, maybe the video goes out, maybe the sound goes out. You can watch the YouTube video. It'll have both of those things. But again, as far as I know, that's the policy, is that everybody has to be in Zoom, because if you could learn on your own, then you wouldn't need summer school. So a lot of students, they really do need the instruction. And to say, I don't need the instruction is basically like, you know, telling somebody that something's not going to work out for you. You know, like, it's like giving a cat medicine. All right, cats don't like medicine. It tastes bad. But trying to get them to eat it is also a bit of a hassle too. You know, if the cat wasn't sick or whatever, if it wasn't licking itself constantly, getting hairballs, then it wouldn't need the medicine. So again, you know, think about what's going on, because this summer course again has different rules, and you better be asking yourself, are you ready to handle this? Anyway, that's it. The next thing I'm going to talk about after this is going to be grades. So we also, during that same meeting, talked about how grades were going to be done. So I'll include that in the next lesson. For now, it's lunchtime, so I'll go ahead and let you guys go.